we're going to be looking at how to solve problems involving direct translations. What this means is we're turning words into math and then solving an equation from that. So for these direct translation problems, they're missing number problems. We're looking for a number, and we're going to give you some conditions about that number so you can figure it out. The first such statement is this: the sum of a number and 8 is doubled. The result is 12 more than the number. Find the number. So the idea here is we're going to use a variable to represent this one number that we are given a few conditions about. And we could use any letter that we want, but I'll use the letter N to stand for number. The first part of the statement says the sum of a number and 8 is doubled. Whenever you have a sum or a difference, again, a sum is addition, you're going to put it in parentheses. If you have a difference, which is subtraction, you're going to put that in parentheses. But we always need to protect our sum because, just like in this case, we're going to be taking multiples of it. So the sum of a number and 8 is doubled. Well, the sum of a number and 8, if n is my number, can be expressed as n plus 8. But because it's a sum, we're going to put it into parentheses. Our statement says the sum of a number and 8 is doubled, so we're just going to put a 2 outside of those parentheses. It says the result is 12 more than the number. So the result is, well, is an equal sign. 12 more than the number would be the number plus 12. So now we have one equation that we can solve. 2 parentheses n plus 8 is equal to n plus 12. We'll solve that by simplifying using the distributive property on the left side of the equation. 2n plus 16 equals n plus 12. We have variables on both sides of the equation, so in order to get the variable on one side of the equation, which is what a solution to an equation looks like, we will subtract the smaller variable from the larger one. We have 2n over here and only 1n over here, so we'll subtract the 1n from both sides. Again, this is an equation, we have to keep it in balance. 2n minus n is just 1n, plus 16 equals, well, n minus n cancels itself out, that's 0. So n plus 16 equals 12. Now I need to do the inverse, or the opposite of adding 16, which is to subtract 16. And as always with inverses, we have to apply them to both sides at the same time to keep the equation in balance. So we have n, positive 16 minus 16, that cancels out, that equals 0. And then 12 minus 16, well, we have two numbers that have different signs and we're combining them, so we can subtract the two numbers. 16 minus 12 is 4. But then we have to keep the sign of the higher absolute value to make it negative. Again, negative 16 is further away from 0 than 12 is, so when we add the 12 back, we're still going to be on the left side of 0. We have n equaling negative 4 here, so that is my solution, but I'm never finished until I check it to make sure that it works. I'm supposing that n equals 4, so now I'll plug it in using parentheses. So 2, and I can use a bracket here if you want. Just to keep those parentheses together, if you like, rather than using double parentheses. Now, as a habit, I'm always going to use parentheses to protect my negative number or any number that I'm evaluating, that I'm plugging in. You may not always need it, but there will be times when you do, and I'd rather you avoid the mistake by always using them rather than making the mistake by occasionally not using them. So then we'll simplify here. Now that I'm removing the parentheses in here, negative 4 plus 8 is really 8 minus 4, or 8 plus negative 4, which is positive 4. So now I can remove the brackets and just replace it with the parentheses again. Negative 4 plus 12 is the same idea as before. This is really 12 minus 4. And I'm going to keep the sign of the higher absolute value, which is 12, so this is 8. 2 times 4 does equal 8, so I have checked this. I know that negative 4 is the solution to this equation.